We're on.
Okay, we have people coming in. Welcome to another of our podcasts, broadcasts, educational casts. My name is Marty Shaw. I've been working at the Delphian School for 25 years. This is my friend and colleague, Sam Silver. Sam is going to assist me today and answer your questions or comments. If you have any questions or comments, you send it in on the Q&A on your screen. So, we have anybody listening?
Yeah, there's 50 people out there.
Great, let's get started. We're gonna start by looking at reading a little bit from this pack, and then we're gonna do some experiments along the way. This is Light Bulb Switches and Batteries by Heron Books. It's available free online. If you haven't gotten it already, I urge you to do so. And Sam, let's bring up the first page.
Okay, here we go.
So this first page, I'll wait till Sam catches up here. The first page is about doing work. Now, when we talk about doing work, we're not talking about like you have a job and you go to work. That's a different definition of work. This definition of work is the science definition of work, and it means to move things. So if you push really hard on something, but it doesn't move, you haven't done any work. Work is moving something. So there are lots of different ways to work, and we're going to go to page 3 and look at a couple. So it says at the top, if a bear scratches its back on a fence post and bends the fence post over, the bear is doing work on the fence post. It's moving. Anything that causes something to move is doing work. And for something to do work, it must have energy. Energy is the ability to do work. Okay, we're going to jump right into the next page. So there are different kinds of energy. There are different ways to move things. There's heat energy, like it shows you on this page. Have you ever been around a campfire and you see these little particles going up in the air? So what's moving those little particles up in the air at the campfire? And I want to show you this. Heat energy is being used here.
Probably can't really be seen. I'll bring it up over
Okay, you'll bring it up over there. So big companies that make energy, make electrical energy, use heat. They take coal or oil and burn it. The burned oil turns water into steam. The heat turns water into steam. The steam spins around these big metal pieces, and these big metal pieces are attached to a motor. And when you, thank you, Sam. And when you have a motor spinning, that makes electricity. I'm going to show you that right here. Right there in the middle, right under my finger, is a motor. And if I take this handle and I move it, I'm making electricity. Well, this is the way the big power companies make electricity, but they don't use something like this. Thank you, Sam. They don't use they don't use this. They use big, huge motors, and so they make a lot of electricity. But I just wanted to show you that motors can make electricity, and that power companies use heat to make energy, to make electrical energy. Okay, let's take a look at page 7 and see what some other kinds of energy are.
Page 7 coming up. Here we go.
Yeah, there's light
so you can
energy.
see what they're seeing.
Okay, there's light energy. So isn't it strange that light can make energy? I mean, it makes plants grow, but how does it make energy? It says here, light energy from the sun makes the atoms that the street is made of move faster. The street feels hotter. I'm going to show you something else. Sam, can you, good. I'm going to ask you to pick this up. Is this big enough, Sam?
Wow.
Who knows what this is? If you know what this is, send in your Q&A, send in and guess what this is. You might have seen these on some roofs in your neighborhood, or you might even see them in a field. I've seen them in a field nearby. And what do these things do? If you think you know, send in comments. Do we have any comments yet, Sam?
Yeah, so first of all, a lot of people have said hi. We
Hi.
haven't been able to respond because we're just going, but
Okay.
hi, everybody.
Welcome.
Thank you for being here. Somebody said it's a solar panel.
It's a solar panel. Ding, ding, ding. That's exactly right.
Yes.
And what does a solar panel do? It takes electricity, it takes light and makes it into electricity. That's what solar panels do. We're going to put this back down.
Oh, good. All right.
You've done your exercise for the day, Sam.
Done.
Yeah, so that takes light energy and makes it into electrical energy. Now, have you noticed that energy can be changed from one thing to the next? I can take motion energy and make electrical and light energy. Or I can take electrical energy in this battery, and if I attach one end here and one end there, I can make motion energy and light energy. So energy can be changed. One type of energy can change into another. I'm going to show you another. There's motion energy. Now, when I talk about motion energy, I like to think about ready to move and moving. So here's a rubber band, and if I pull this back, it's ready to move. And if I let it go, it's going to be duck down because I don't want it to hit you. Now it's motion. So it changed from stored or ready to move energy to moving energy. And here's another one that can do that. This is another one of my toys. I'm lucky because I get to take toys to work. So if I wind this up, now this has stored energy. And if I let it go, it has motion energy. I hope you're not afraid of spiders, Sam.
I am a little bit, but this guy looks harmless. I think I could defend myself.
Okay, so this is stored energy, ready to move, turned into motion energy. Here's another one of my toys that'll do that. Here's a little toy car, and if I pull it back, now this has stored energy, because when I let it go, off the end of the table, it changed stored energy, ready to move, into motion energy. Some of you might have some wind-up toys. I wanted to show you how they work. I'm gonna come around and show you this because it's very small. So I took apart one of my wind-up toys. Can you see this?
Here, let's see how that's looking. Bring it back a little bit. It's pretty hard to see.
No?
The focus isn't great.
Okay, well, it has a spring here, and when I wind up the spring, it can move. This is how your little wind-up toys might move. It's ready to move, stored energy, and moving, motion energy. Now, what about this? How does this change? If you think you know, send in a Q&A and tell me what kind of energy does this use and what kind of energy does this make? Now, what is this anyway? I certainly don't need it.
Ready for some answers?
I'm ready for some answers.
Kai says it takes electrical energy.
That's what this part's for.
And turns it to heat energy.
It turns it into heat. You're right. There's another kind of an energy that it turns it into. Did anybody figure out what that other type of energy is?
Cypress says electrical to heat. Kai says it makes heat energy.
It does. You're all right.
Mina gave us a little bit of a different answer. She says it takes motion energy and turns it into heat.
Well, this is using electrical energy. So that's what it's, but you're right. It does create motion energy, because if I were to plug this in and turn it on and heat up Sam's hair, you'd see his hair blowing. So it creates heat energy and motion energy. I don't know if you can see that little fan in back. Is that all in focus?
Let's see. I'm trying to catch up with some of the questions.
Yeah.
You can see a little bit of that.
There's a little fan in back, and so when I plug this in, that little fan spins around and creates motion energy. What questions do we have, Sam?
Well, somebody asked, does it make kinetic energy? I thought that was an interesting
Well, kinetic
question.
energy is a more grown-up word to mean motion energy or moving. And potential energy is the word that's stored energy or ready to move. They all mean the same thing. Stored or potential or ready to move, that's one kind of energy. And the other energy is motion or moving or kinetic. They all mean the same thing. They're just fancier words.
Good. I think that's good. I think we don't have any more questions that I found yet. We actually have over 100 questions, so I'm trying to keep up with them, but I think all of them have been answered in that. I'm running through. If I missed your question and we need to get it, hopefully I'll get it as I catch up to Marty.
Okay, well, thank you for that. Let me just shut off my phone. And thank you for your answers and contributions. Something
Here is
you
an
wanted to say?
interesting question. Somebody asked, can you use electricity to make electricity?
Can you use electricity to make electricity? Well, when I did this, I used electricity and it made this motor turn, and this motor turning made this light bulb light up. Just when I spin this around with my hand, it makes it light up because the motor is spinning. But when I did this earlier, this electrical energy caused the motor to turn, which created electrical energy. Good question.
And then we had a few people asking, as we're showing the books, they asked, where can you get the books?
Okay, Sam, where can you get the books?
All right, I'll answer that. It's where I work. You get them at heronbooks.com. And if you use the code Delphian30 when you're buying, anybody who's attending the webinar, you can get them at 30% off. But all of these books are available at heronbooks.com, and some of them are available for download for free. You'll get a link after this that will send you an email.
Like this one, is this available for
I
free?
actually don't remember. I think it is.
I think it is.
So you'll get a link emailed to you after this, and anything you can't get, like I don't think the Everyday Electricity is available for free download right now, but you can get that for 30% off. Or if you want to buy the actual book so you can do the whole course at home and you want to have the book, you can get all those. We're trying to make them as available as we can because we know most of you are out there stuck at home and you need something to do.
Do study guides come with the book, Sam?
Yeah, each book comes with its own learning guide, which we don't actually have an example here. Let me see if I have one. It's worth showing you if I can find it real fast. Nope. Anyway, a learning guide is kind of a step-by-step approach to learning. It just writes, read these pages, and then gives you an activity to do so you can practice using it and walks you through, which helps you learn. If you don't have a parent to sit down and walk you through everything, or if you're a parent and you want to turn the learning over to your kid, it gives you a chance to do that. So it's really nice for that. So heronbooks.com is the answer to all of those questions. You can get them all there, or wait and see what's available as a free download because you'll get an email right after this.
Well, great. So I hope you take advantage and can get a free download, or if you're interested, can get some of these so you can do them at home. And once you have them, it's not only you that could do it, it's your whole family could do these courses.
True. And Jolly says, staying at home is so boring. We know. That's why we're trying
That's
to
why we're
help,
doing
so,
these things, to give you something to
hopefully.
do and maybe make learning a little bit interesting.
Yeah, hopefully it helps.
So now, do we have everyday electricity on?
We don't have that. I can't show that on the
Okay,
screen.
well,
I don't have
I'm
the,
going to read this to you. I'm not going to read the whole page, but you probably know some of this already. It says electricity does work for us, and we use it in many, many ways every day, from light bulbs to vacuum cleaners to amusement park rides to computers to TV to motorcycles. But what exactly is electricity? That's a good question. And we're going to talk about what that is now. To answer these questions, we need to know a little something about matter. You know, stuff. I like to use the technical term stuff when I'm talking about matter, like tables and chairs and trees and rocks and air. Okay, so ideas or thoughts, that's not matter. But anything you can see or touch or feel, that's matter. And matter is made up of very tiny, tiny pieces of matter called an atom. Do you have a picture of the atom, Sam?
I do. Let me pull it up.
Okay. It should look something like this.
All right, here we go.
Okay,
We'll skip ahead to the atom.
okay.
We have
Good.
this, and then we have
So
some other
this
cool ones.
This is a model of an atom. Oh, Sam had a cool one there.
You want that one?
No, I like mine better. Because it shows you the different parts.
Well, watch this, Marty. You ready?
Whoa, whoa. Now, the nucleus, it says nucleus. Nucleus is a word that's used to describe the center part of the atom. It's also a word that's used to describe the center part of a body cell. So if you're learning about biology and you're learning about the nucleus in a cell, that just means the center part. In a cell, in a body cell, that's where all the information is kept. And here, we had a little smoking going on there.
Wait, actually, almost. I think you need to show that. Right?
So we're going to learn about short circuits. So what happens,
Let me
that's
stop
hot.
this screen share. You guys have to see this.
So what happens is this part was touching there. Now, this battery can do work as you just saw. It can light light bulbs, right? But if these two touch without anything in there called resistance, which we'll talk about in just a minute, then it lets all of the electrons go through really, 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 really fast, and the wires get really, really, really hot, and they start to smoke. And that's what we saw. We saw them start to smoke. I don't know that I want them
No, I think it was the box. You see where it melted right there? You actually melted a hole in your little plastic thing.
in my little, in
Look.
this? Oh, in this?
Look right here.
Oh yeah, look at that.
So when Marty and I get together, we tend to create some problems.
Sometimes we burn
smoke,
things.
and we almost just burned this box down.
Can
I
you
don't
see
know if
that?
You can see right here,
That little,
but that just started smoking because we put a little too much energy into it.
because we had the wires, I wasn't careful when I put the wires back and they were touching. Also, the battery can get hot.
Huh.
I'm gonna
Okay.
disconnect, well, this a little warm.
Ah, just kidding. It's not. But interesting.
All right, so now back to our show. So there,
We're doing model of an atom.
we're doing models of an atom.
Let me pull that back up.
Okay, so atoms have three basic parts.
People
and
can't
they-
really see that. What
Okay,
it is.
fine, show them your atom.
We can go back.
The nucleus, which has the protons and the neutrons. Protons are positive and neutrons are neutral. They're not positive or negative. And then the electrons are negative. So these words positive and negative, they're just words that scientists use to describe the fact that the protons and the electrons are attracted to each other. And the protons want to repel each other or push each other away. You going to show my picture now? Oh, you did get that one. I don't know, did I?
Do you want this one?
Well, that's the one that shows you the protons. Now, they really aren't marked with a P, and they really, the electrons are really very, very tiny compared to, I chose that picture because it shows you the electrons are a little smaller.
Interesting.
Actually, the electrons are much, much, much smaller. If a proton weighs about 1,800 times more than an electron.
Wow.
Protons and neutrons are about the same, but protons weigh about 1,800 times more than an electron.
Wow.
Okay.
Should we stop and do a little bit of question and
Sure,
answer
let's
right
do
now?
some questions.
Okay, because we have 106 questions.
Okay.
I don't think we'll get them all, but let's see if we can get a few. Sorry, let's get down to the more recent ones. Whoa, there's so many. Sorry, it's just taking a little long. Somebody mentioned, oh, this is the most important comment. Somebody says they like my model better.
Well, fine.
Thank you, Lila. I so agree. All right.
Okay, so
sorry, yeah.
So
I'm having a
while
little
Sam
trouble with this.
is looking for an interesting question, let me just tell you, some atoms
Oh, here we go.
have electrons that can get away. Don't forget, atoms are like, do I have my little, no, there's one. Okay, I guess I don't have a battery. Oh, here are my batteries.
Milo likes yours better, just so you don't feel too bad.
Thank you, thank you. So, if this was this is a magnet, it's not really an electron, but they act similar to electrons in that if you have a negative here and a negative here, and what, did you see what that did? Try that again, I'll show you on the white paper. It pushed it away, it knocked it over. So similarly, some elements, some things like copper, this is copper wire. Pennies are made of copper wire. My little wires here, you might be able to see inside, it has a clear plastic coating, and you can see the copper wire. This lets electricity, or moving electrons, that's really all electricity is, moving electrons. And you can see these electrons move through a material like copper. And so there are three parts of electricity that I'm going to go over with you now. One is called voltage.
You want to show those?
Yes.
Put those up. We had a few questions on what's a proton, neutron, and nucleus. Do you want to just run through that?
Sure, let's do that.
Just to make sure.
Yes.
Great. We'll do a quick run through and then we'll hit the voltage. Sound good?
Yeah.
Great. We'll show yours because Milo likes yours better.
Thank you, Mila. Okay, and what's the question?
Question was, what was a proton, a neutron, and a nucleus?
Okay, so a nucleus is just the center of an atom, like in the picture you see here. Do they see that picture?
They see that picture.
Okay, and so the nucleus is made of these parts of an atom called protons and neutrons. And you could think of it as sort of a solar system where the center part, the nucleus, is like the sun, and the electrons are like the planets that orbit the sun. So similarly, in an atom, you have the nucleus, which is made of these parts, which we call protons and neutrons, and you have the electrons circling them like the planets.
Perfect.
I hope that helps.
Perfect.
Okay, so are we ready to talk about voltage?
Yep. Just trying to find the right slide. This is the one you want, right?
Yes.
Okay.
So we're talking about these batteries any batteries provide voltage. It'll say 5 volts or 6 volts or 1.5 volts. And that tells you how hard the electrical push is. So the more volts you have, the more it's pushing these electrons. So in this picture, it's not much of a push. The river here is not, the water is not flowing very fast. You could say it has a slow current, because current is just the flow of something. In this picture of the river, it's the flow of the water. In electricity, it's the flow of electrons. Let's take a look at the next picture, Sam. Here we have a little more voltage going on, a little more push. You can see that water is really rushing through.
Interesting.
That would be like high voltage.
So
higher.
Even though there's less water, there's more push.
There's more push.
So the push is the voltage.
Right.
You could have a lot of current with a low push.
You could have a lot of current with a low push, yeah, like on a wide river.
Yeah, or you could have a little bit of current with a high push, like a pressure washer.
Right.
That's helpful to me.
Yeah.
Okay, great.
Let's go to the next one, and we're going to talk about the second kind, maybe it's the third, and that is resistance. It says, remember, electrons are negative and want to push each other away. A battery, like this, has lots of electrons in a small area, and these electrons want to get away and are willing to do some work. That is, to move something to get to the positive side of the battery. Just like we saw earlier with when we connected these two things together and we saw smoke. So resistance is something that slows down the flow. In this picture, it's slowing down, the rocks are the resistance. It's slowing down the flow of the water, or you could say it's slowing down the water current. In an electrical system, you have light bulbs like this, or motors like the one that's, oh, where's my motor? Here's my motor. This is making resistance. It's slowing the electrons down, making them do work before they go back to the other part of the battery. So we learned 3 things. We learned about current, the flow of electrons. We learned that batteries provide voltage, which helps push the electrons faster. And we learned about resistance, like these little light bulbs or motor, which slow things down. Okay.
Good. Now, we got a few more questions again, just to some people asking to review some of our basics.
Sure.
Which I think is a great idea. So the first question was, what is an atom?
Okay. An atom is a very, very, very tiny part of matter. Let me give you an example. Scientists believe there are 200 billion stars in every galaxy. And some scientists believe there are about 200 billion galaxies. So if you took the last little part of your finger, you would have more atoms in your finger than all the stars in all the galaxies in all the universe. These atoms are incredibly tiny. And so we can't really see them very well. We can't see certainly the different parts, but scientists do experiments, and when they do the experiments, they get results that lead them to believe, aha, this is what an atom looks like. And oh, well, let's see, it does this. So maybe, and then they learn a little more and more about them. And science is a study of nature and how the world works. And so somebody hundreds of years ago came up with the idea of the atom. And since that time, it has been changed to make it more exact, and more experiments are done. So now we pretty much know a lot about an atom and its parts. And you're getting the basics here. I could talk for days about atoms and what they're made of and this sort and all the different things, but this is just sort of a basic intro.
Great. And then a couple people asked again, could you remind us again, nucleus? What is that?
Nucleus is the center. So if this is a model or a picture, an artist's drawing of an atom, the nucleus is this center part right here. Now the whole thing is the atom, but the nucleus is the center part that holds the protons and neutrons. And the funny thing about an atom is it's mainly empty space. This is just showing you all the parts, but it doesn't really give you an idea of how empty it is. If you were in a baseball stadium, Sam, I know you'll relate to this. Sam loves baseball. If you were in a baseball stadium, the nucleus and the whole baseball stadium was the atom. The nucleus would be like a marble behind second base.
Okay.
And these electrons would be like pieces of dust flying around in the outfield. So you can see it's mainly empty space.
That's kind of a crazy thought, huh? If our hand is made up of atoms, and atoms are mostly empty space.
That's right.
So if we were to really look at the smallest level with a giant microscope, my hand is actually mostly empty space.
It's mostly empty space.
Didn't work. But that is crazy to think. Like, what an interesting concept.
Yeah.
Great. All right. Well, I think that's it for the questions for right now.
Okay. So I think that was pretty much what I wanted to go over.
Oh, great. Then we can get into some of the larger questions that are going to
Yes, let's do that.
A little bit. So Alette had said something really cool. She said she once generated electricity with a fan, and she thinks she made 1.5 volts. Is that possible?
Absolutely. You might have seen these big windmills and on the side of the road or at farms. And what happens is these windmills spin around and they're connected. Inside the windmill is a motor. And so remember we talked earlier about how you can change one type of energy to the next. Well, what a windmill does is it takes motion energy and changes it into electrical energy, just like my little hand generator here. And so, yes, you could, that's, as a matter of fact, I have something in my science lab, which is sort of a windmill with these big blades, and you can take the blades and make whatever shape you want out of the blades, and it's attached to a motor, and we can attach something to measure the electricity, and you could see how the different shapes and different sizes of blades and the different angles of the blades will make different amounts of electricity, but you could absolutely do that.
All right, Jesse asked, is rubber an insulator?
Yes, rubber is an insulator, and so is plastic. That's why these have these plastic coverings, because the plastic won't let the electricity, the electrons go through. It won't, it'll keep them on the wires and moving through the wires, but not come out. That's why you can touch an electric power cord and not get a shock. Rubber will be fine, so will plastic.
Excellent. All right, let's see what's next. We have a whole bunch of great questions.
Oh, great.
Somebody wanted to know, do atoms, are different atoms bunched together?
Are different atoms bunched together? Yeah, you could have atoms that could be bunched together to form compounds. So an atom is from one type. Let's say you have an iron. Iron is one type of material, and you could have an iron atom. And when it meets up with the oxygen, they come together and they form this new substance that we call rust. Rust is just when iron an iron atom, for instance, combines with some oxygen atoms and it forms something new. And that's what it does. That's how we get materials. All of these things here, I mean, I have some things like iron, this is iron, or this is copper in here, this wire, but most things are made up of compounds, which are two or more types of atoms that come together and join.
Like water is a good example, right?
Water, right. Water is made up of, you probably have heard, H2O. That stands for 2 hydrogen atoms combined with 1 oxygen atom. Now, hydrogen by itself is a colorless gas at normal temperature. And oxygen is also, at room temperature, an invisible gas. And it's what we breathe in and breathe out to get energy. One of the things that helps us get energy. And so when you take invisible hydrogen gas and you combine it with invisible oxygen gas, you get liquid water. Because when these atoms combine, they change the way they act. I'm going to tell you something else. There's this atom called sodium. It explodes if you put it in water. You've seen that, haven't you, Sam?
We should do that sometime.
Not indoors. I did it in my lab, and I put a container here, and I put the water in it, and I dropped the sodium in, and sparks were left in the ceiling. So we're not going to do that indoors. But anyway, that's sodium. It's poisonous. Chlorine is also a gas that's poisonous, but you combine the two together and you get non-explosive, non-poisonous table salt, the stuff you put on your French fries. And so just to show you that when these atoms combine, they can act differently.
All right, we only have about 5 minutes left, but we have a few questions. One, I think we can answer pretty quick. Somebody asked, what is an insulator? We covered that yesterday, but I thought we could do a 30-second review of that today.
Well, I started to make something to show you. I don't know if you can see this.
Yeah, let's see how it looks.
I'll hold it up.
Yeah. Probably
Not so
have some
much.
trouble seeing it.
Okay, well, these green glass beads over here have this little tiny ball here. So this glass bead, green glass bead, is like an atom, and the tiny ball is like the electron. And here, this is a glass bead also, but if I put some of these in here, you can see here, you might be able to see, here the electrons are free to move.
That's actually a really cool demo. I bet you guys can't see it at all. But this is really cool. You can see how the electrons can move or they get stuck.
Yeah, so these guys are all stuck and they're not moving, but these other ones can move.
But the quick answer is an insulator is a material that doesn't conduct electricity. Like electricity can't flow through it. So
Right.
if I put a wire here and a wire here, this is a conductor. If I put those two wires, the electricity wouldn't flow.
Well, let's do that. Let's show them.
Okay.
So here we can attach this to our light bulb, to the other light bulb, and we're going to attach this to here, and we're going to attach another one of these to here. Now metals are good conductors. So if I did this, the metal is conducting. If I attached it to the cardboard is not a good conductor. It's a good insulator. Nothing. As a matter of fact, this is a switch. And so if I attach one end to here, this is all metal. This part is metal. And so the electrons can go from the battery through here, through the metal, through, I don't know if you can see it, there's metal at the bottom here, and it touches here, and it could make a circuit.
Should we do a don't try this at home test?
What did you have in mind, Sam?
Is my finger an insulator or a conductor?
I don't mind if you don't mind.
So the reason this is okay is this battery is not super strong. You wouldn't want to do this with strong electricity.
Also, you don't want to clamp these alligator clips on Sam's hand or you will hear him scream, but I can
Marty
go.
might want to.
I can go like this and nothing. Nope, nothing. It's not a good conductor.
What about, let's try these scissors.
Let's try the scissors.
So the plastic end of it, I predict not a conductor.
Nothing.
Now the metal end, I wonder what kind of metal it is, because some metal doesn't conduct very well. Let's see.
All metal conducts well.
Really? I thought there were some metals that didn't. Does that just mean like plastic coated? Is
Yes.
the problem? Interesting. So this says they're stainless steel, so it should conduct, right?
And it does.
The light is on.
And it does. So things that are metal conduct electricity. Things that are not metal usually don't.
Will it conduct? I guess they must be connected.
They're connected.
That is pretty cool. All right, somebody asked a question that I thought we might have time for, but we're not going to, which is what are the different kinds of energies? That you can get from the download pack, I'm pretty sure.
Well, there's
I think
stored
light bulb
energy.
switches and batteries is. We could run through it really fast. There's stored energy. So like a battery is stored energy.
Yes.
Even these scissors could be stored energy if I hold it here, because it's ready to go. And then I drop it.
So there's stored energy. There's lots of different types of stored energy. There's electrical stored energy or electrical motion energy, light energy,
Like here.
there's heat energy. This is only a few of them. There's actually a lot more. There's nuclear energy, which is, that's another whole seminar, which we
But-
could do.
Because we're running out of time, just so you know, this will come into your email. You can download this book for free, and it will have a bunch of those and a bunch of examples, and that should answer that pretty well. I know there's a ton of questions we didn't get to. I'm so sorry, but we are actually out of time now. Thank you for coming.
Thank you for coming. Remember, the cure for boredom is curiosity.
Yes.
Stay curious about how the world works and take advantage of this time to learn about things you always wanted to know about. And have a great time. See you next time.
Excellent. If anybody has any questions, you can still post them in the Q&A. I'm going to leave this up for just a second. We'll leave that up. Go ahead and post in the Q&A. It was great. I'm glad we didn't burn anything down this
Me
time.
too.
We came close.
We came close,
But
better luck
we
next
did
time.
it. Yeah. All right. Thank you, everybody. We'll see you next time around.
Bye for now.